Now in the previous lectures, we have learned main properties of dynamic programming, two different methods of dynamic programming, and we have talked how can we identify a problem that can be solved using dynamic programming. From this lecture on, we will talk about common dynamic programming problems. So as we mentioned, dynamic programming is an optimized version of divide and conquer. So that's why we will take the problems that we solved in divide and conquer section and see what was the problem with them, and then we are going to solve them using dynamic programming. So as you remember from the previous section, the first problem that we are going to solve is number factor problem. But here we are going to use, in this case, dynamic programming. I'll show you how to solve it in both methods of dynamic programming, which are top-down method and bottom-up method. So the problem statement is like this. We are given the number of n, so we need to find out the number of ways to express n as a sum of 1, 3, and 4. So I have explained this problem in our previous section, so to understand this definition very clearly, I'm just going to show you two quick examples over here. So let's say we are given number 4, so we need to find out number of ways that can be expressed using 1, 3, and 4 over here. Now in this case, number of ways expressing 4 by using these numbers over here is 4. So as you can see that we can express it as a 4, then we can express it 1 and 3, then we can express it 3 and 1, and then we can express it as 4, 1 over here. So if we count these expressions over here, we can easily see that the number of expressions are 4. Now let's look at another example. So in this example, we are given number of 5, so the number of ways to express 5 using these numbers over here is 6. So as you can see, this is how we can express 5 using these numbers over here. So hopefully with this, our problem statement is very clear. So as we explained in previous section, this problem has optimal structure property. So that's why we have implemented in our previous lecture divide and conquer approach. Then after implementation of divide and conquer, our algorithm was like this. So we have calculated 3 recursive functions, then we have sum of them to get our result over here. So we have explained how we found these recursive functions in our previous section. So if you haven't watched that video, I advise you to go back and watch that video to understand how we get these recursive functions over here. So as I explained them in our previous section, I'm not going to go to the details of these recursive calls over here. So here I'm just showing that the algorithm from previous section was like this. Now based on this algorithm over here, we can easily see that our recursive tree looks like this. So here, if we take number factor problem for the 8, so first we are calculating recursive call for number factor 7, then number factor 5, then number factor 4. So these recursive calls are getting from 8 minus 1, 8 minus 3, and 8 minus 4. So we are using these numbers over here. So if we closely observe this tree over here, we can easily see that we have a problem over here, which is the same subproblems gets repeated multiple times. So here, for example, if I go to the number factor 7, you can see that here we have calculated number factor 6, number factor 4, and number factor 3 over here. And number factor 4 over here is get calculated one more time over here and one more time over here. So these recursive calls over here are repeated multiple times. So here we can see that we have overlapping subproblem property, which means that we are solving same problem multiple times. So if we have overlapping subproblems property in a given problem, we can easily solve this problem using dynamic programming. So if we implement dynamic programming in this problem over here, we can easily get rid of these multiple calls from here. So when we are calculating number factor 4 over here, we can save it, and after saving it, we can easily get rid of these repetitive calls from here. So with this, our problem becomes more efficient, and this is optimized version of divide and conquer solution. Now let's see how can we use dynamic programming for this problem over here. As I mentioned, I will show you how to solve this problem in both methods, top-down approach and bottom-up approach. Now the first method is top-down approach. Now here, the idea is if you solve problem using divide and conquer approach, this means that implementing top-down approach is not difficult. So here we have an algorithm of this problem using divide and conquer approach. This algorithm is explained in our previous section, so I'm not going to go to the details of this algorithm one more time over here. So if you want, you can go back to previous section and watch this. Now to convert this algorithm from divide conquer approach to the dynamic programming, we will follow 4 simple steps. Now the first step is we need to create an array, and then we are going to pass this array as a parameter over here and save the results in this array over here. Now after the first step, our algorithm becomes like this. So dynamic programming, this is the name of array over here. Now the second step is, before continuing to the recursion, we have to check that if the problem is already solved or not. So if the problem is already solved, we are not going to calculate it again, we are just going to use the stored one. So in this case, we have to add one more condition over here in which we are going to check that if this problem is calculated or not. So if it exists in this array over here, it means that it is calculated. Now the third step is, in case we have not solved this problem before, we continue to the recursion over here, and after solving the problem, we are going to add this problem to our array over here. Now in the third step, we are going to add this problem to the array over here for avoiding in the next steps over here. Now after adding this one to our array over here, in the last step we need to return the value from this array over here. So in the last step we are going to return the value from this array over here that we calculated before. Now these are the 4 steps for converting divide and conquer solution for any given problem into top-down solution of dynamic programming. So here you can easily see that in the first step we have passed array as a parameter. In the second step we are checking that if the solution exists in this array or not. In the third step, if it does not exist, we are adding it to this array over here, and in the last step we are returning it from the array over here. Now in the next lectures you will see that whatever solutions we have found from the divide and conquer approach, we will use these 4 steps to convert this solution to top-down approach of dynamic programming. Now to understand this algorithm, let's see how this array works internally. Now it's very important to understand it because it makes our life easier when we are solving problems using bottom-up approach. So in this case we are going to use the same table in reverse order. So let's look at for this problem in top-down approach. Now in this case, as we said before, the value for number factor problem in 0, 1, 2 and 3 is obvious, so we have filled these values over here. Now in the next step we need to find out the value of 7. Now we know that finding for 7 number factor problem, in this case the expression will be like this: 7 minus 1, 7 minus 3 and 7 minus 4. So we need to find out these recursive calls over here. So if you go to these recursive calls, you see that some of them is not calculated. So this means that in the next case we need to find out number factor for 6 over here. Now for 6, one more time we are going to write the equation like this. We need to find out 6 minus 1 number factor, so which is number factor 5, then 6 minus 3 number factor, which is number factor 3, then 6 minus 4 number factor. Now here to calculate number factor 6, we need to find out number factor 5. So to find out number factor 5, we need to write equation for number factor 5. So as you can see, we are starting from top and coming down one by one. Now for finding the number factor 5, we need to find out number factor 4, which is 5 minus 1, plus number factor 2, which is 5 minus 3, plus number factor 1, which is 5 minus 4. So as you can see, to find number factor 5, we need to find out number factor 4. So this means that we need to write equation for number factor 4. Now for number factor 4, the equation will be like this: number factor 3 plus number factor 2 plus number factor 0. So as you can see, the values for these number factors over here is obvious. So this means that we can calculate this number factor 4 based on these values over here that we have before. So these are acts as a base condition over here. So we are going to calculate it number factor 3 plus number factor 2 plus number factor 0 over here. So after calculation, we can easily see that the result for number factor 4 is 4. Now based on this result, we can calculate number factor 5. So if we calculate it for number factor 5, it's going to be like this. So 4 is coming from a number factor 4, then 1 is coming from number factor 2, then 1 is coming from number factor 1 over here. So the result is 6. Now if we continue one more step, we can calculate it for number factor 6, and if we continue one more step, we can calculate it for number factor 7 over here. So as you can see, by going from top to down, we have calculated all results over here based on the top-down approach. So our array over here gets filled like this when we are using top-down approach. Now in case of bottom-up approach, this array gets filled in reverse order. So we are starting from the number factor 0, number factor 1, number factor 2, number factor 3. So these are the values that are given, so we don't need to calculate them, we are just filling the table. Now based on these values, we are going to calculate the next value, which is number factor 4. Now to calculate the number factor 4, the equation is like this: number factor 3 plus number factor 1 plus number factor 0, because in this case 4 minus 1 is 3, 4 minus 3 is 1, and 4 minus 4 is 0. Now after calculating this one, we can continue to calculate the number factor 5. So in this case, the equation for number factor 5 will be like this: number factor 4 plus number factor 2 plus number factor 1. Then after calculating number factor 5, we can continue to calculate number factor 6. Now in this case, the equation will be like this, based on these numbers over here. Then we are going to calculate it for number factor 7 over here. For number factor 7, the equation will be like this. Now after calculating it, we can fill these values very easily. So for number factor 4 is going to be 4, and for number factor 5 is going to be 6. Now for number factor 6 is going to be 9, and for number factor 7 is going to be 15 over here. So as you can see, bottom-up approach is reverse version of top-down approach. Now to find solution for bottom-up approach is very difficult, because if we don't know how the processing is happening internally, we can never come up with bottom-up approach. So the ideal way to find out bottom-up approach is that first we need to find out divide and conquer solution. Then after finding divide and conquer solution, we can easily convert this divide and conquer solution to the top-down approach. Then we can reverse top-down approach to get the bottom-up approach over here. So without knowing how this array internally works, it's very difficult to come up with bottom-up approach. Now, based on this internal work over here, the bottom-up approach algorithm for this problem is going to be like this. So here you can see that first we are filling the values in the array. Then based on that, we are calculating values and inserting this array over here. Now, this is how bottom-up approach algorithm looks like. So with this, we have come to the end of this lecture. So in this lecture, we have discussed dynamic programming for number factor using top-down approach and bottom-up approach. And based on these algorithms over here, in the next lecture, we are going to implement a method which solves number factor problem using dynamic programming in both methods, top-down approach and bottom-up approach. So see you in the next lecture.